Let's talk about how to choose the right architecture when wrapping an API with MCP. Hi, I'm Akshay from ScaleKit and welcome to the API versus MCP series. At a high level, an MCP wrapper translates an existing API into an interface that AI agents can use like functions. Instead of humans reading docs, agents discover tools. Each API endpoint becomes an MCP tool with clearly defined inputs, outputs, and the behavior. Inputs are described using schemas, things like parameters and their data types and the descriptions. Outputs are structured responses, in some cases unstructured, but structured helps. So, structured responses that basically help the model reason and take further actions. From a security point of view, the security behavior is like always explicitly defined. So, once you have decided to wrap your API with MCP, the next question becomes how you wrap it. The wrapping strategy you choose has a big impact on how agents reason, plan, and execute the tasks. So let's walk through the 4 common patterns. First is the direct translation. This is the fastest pattern to implement. Each API endpoint maps directly to one MCP tool. A REST endpoint becomes a function, very little logic in between. The upside here is speed. There's minimal wrapper logic, and you can often generate these tools automatically from OpenAPI specs. The downside is that agents now see every low level detail of your API, which means too many tools, inconsistent naming, and internal design choices are now leaking through. This approach works best when your API is already agent friendly and your goal is to expose MCP tools quickly without handcrafting wrappers. So next is capability aggregation. Many real-world APIs split related functionalities across multiple endpoints. For example, create, update, delete. All are separate API calls. For agents, reasoning across these discrete tools can be noisy and unintuitive. With capability aggregation, you group related endpoints into a single semantic tool. Instead of multiple invoice endpoints, you expose something like an invoice manager. Internally, that tool may call multiple APIs, but externally, the agent sees one clean interface. The benefit is a much clearer mental model for the agent. You also gain space for orchestration, validations, and better error handling. The only trade off is high design effort. You have to think about the naming, structure, and behavior carefully while designing semantic tools. This pattern is best when your API is fragmented and needs a higher level abstraction for agents to reason effectively. Third, context-aware wrapping. Capability aggregation simplifies tools. Context-aware wrapping goes one step further. Here, the MCP server maintains short-lived state or memory between calls. This is useful for multi-step flows like search, select, and then update. Stateless APIs don't understand the intent across steps. Context-aware wrappers do. They can track session state, intermediate selections, or workflow progress. This enables much more natural conversational interaction with agents. The trade-off is complexity. You now need to handle session lifecycle, timeouts, stale state, and resets. So use this pattern when your workflow require chaining or short-term memory that the underlying APIs doesn't support. Finally, hybrid wrapping. This pattern mixes MCP tools with direct or internal API calls. Only selected capabilities are exposed as MCP tools. Other endpoints remain internal or are accessed internally by trusted services. This is common when working with legacy systems or when MCP adoption is more incremental. The benefit is flexibility and lower risk in this case. You can experiment without rewriting everything. Of course, the downside is consistency. You need clear documentation and boundaries to avoid confusion. Hybrid wrapping works best when you want to introduce MCP gradually rather than all at once. Now that we understand these different ways to wrap APIs with MCP. Let's see it in action, and I'll switch over to a live code walkthrough. In this code, I have an API mounted on the same server, and I'm serving the MCP on a different path. So for API, I'm using fast API. For MCP, it's fast MCP. API is available on the root path. Fast MCP is available on /MCP. So the use case that I have taken looks something like this. So I'll first go to the api.py file. When you see a /customers and it's a get customers, I want to find the customer by email. What I'm essentially trying to do is have a couple of APIs in place and then show the different ways of wrapping them as MCP tools. It's a ticketing tool, and that's how the endpoints are also like /tickets/customers. First API is get customers, and which will be /customers by a query parameter of email, and it calls the store a common interface. We can go through it further where it gets by email the entire customer object. Similarly, for tickets, this time I want to create a ticket. This is a post call for create ticket, and the create ticket request will need the customer ID, title, and description. If you see closely, when the way this API is created is first someone needs to know who the customer is and their customer ID, and only then the create ticket request would work. Customer ID is not the same as email, it's an internal ID, and then we call the create ticket. And yep, this is how the ticket will be created. All of this information is being saved in memory. And then the last one, which is when a ticket is created, you want to add a node to that ticket. And of course, here you need the ticket ID. And as part of node, I have just taken a parameter called message. Again, it calls the common interface, the common implementation in this case. Tickets by ID, you get the ticket first, and then you add a node to it. All right, so these are the APIs that are defined. Before I really jump into the MCP, I just wanted to quickly show you the 3 endpoints, how they work. John at acme.com. You might be wondering how this John was created. I will push this code onto the repo and put it in the description. It found John with the customer ID CUST_1, and I want to open a ticket with title printer issue and paper jam. All right, the ticket got created. Now for that ticket, I want to add a note called tried power cycle. At this point, this is how the 3 endpoints would work. Now let me go back to the code and go to mcp_server.py file. So let me first go to the tool. The upper part that you see from here to here is the session management. Here, MCP has a standard header called MCP-session-ID, and I'm making use of that for one of these patterns. That's where this helper piece comes into play. But I really want to jump into the tool first so that we can see how the mapping happens. I have a tool called create ticket direct. This direct is telling that this is a direct API call. There is no aggregation as such that's happening. So it is pretty much like what the API is doing. For getting the ticket, all I need is the customer ID and the title and description of the ticket. So we get the customer and we create the ticket. Now, there is one very important thing with these tools is that for demo purposes, I'm using the same container, which is hosting the APIs and the MCP both. And because the code base is common and shared across MCP and API, I am directly making use of the interfaces or the common code in here to directly invoke them. In other cases, it might be possible that you have your APIs hosted as a separate service in separate containers, and then the MCP is hosted separately. In that case, all you need to do is, instead of calling the interface directly, you would just make the REST calls, or whichever way the API interacts with, you would make the calls using over HTTP or gRPC, or in whichever way API interacts. All right, back to create ticket. This is all you need to do to create the ticket. And this mimics our create ticket endpoint. The open support issue. Now, this is an aggregated ticket creation with automatically a note being added to the ticket. Now, we first need to find the customer. This is our first API call. Then based on that, we'll get the customer ID. we need to create a ticket, which is this part. And now once the ticket is created, we need to invoke the add note API. So this is how we aggregate multiple APIs into a common semantic tool. In this case, it's called as open support issue. Now the third one, which is where we need session management and state management. So this is where I would go with this one first. Think about that someone is interacting with this MCP server, and during the conversation, the select customer tool gets invoked. Now, all select customer tool based on email would do is it will return the customer. But this time, if you see, in addition to returning the customer, it saves the customer ID in the MCP hyphen session hyphen ID that will remain for that particular session. Now for that session, the customer is already known. All the further activities, MCP server does not need to explicitly every time ask that for which customer. It doesn't need to do that because it already knows which customer is in context. First, we do a select customer through our natural journey of interacting with the MCP server via client. And then there is a create ticket. This time, if you see, unlike the aggregator pattern where we need to explicitly combine email and ticket level descriptions or title, this time we are only asking for the ticket related details because this is create ticket. And we get the customer ID from the session state. Again, in this case, it's local in memory. For distributed cases, can be put in Redis or some other data store. Once we get the customer ID, we invoke the create ticket API with the customer ID and the title and the description that is being passed. And now we got the ticket. All we need in this case is to save that ticket ID, because if we want to further perform more operations as part of this session, we can use that. We'll save it in last ticket ID and return the response. Now, the third tool is about adding the note. Because it's only about adding the note, we should ask for only the details which are note related. As part of the session, we already know who the customer is, what the ticket ID is. So all we ask here is the message. We get the session state, we get the ticket ID, and based on the ticket ID, we invoke this method to add note or an API. And once all of this is done, remember we are still in the same session. The connection hasn't terminated. Session ID still remains the same from the client side. And that's why MCP server is able to process all this. And there is a simple status tool which just basically returns whatever we have saved so far in the session. Let me open MCPJam. This is by far the greatest inspector tool I have come across. I ran that command to start MCPJam, and this is my ticket MCP. We saw that the same APIs are hosted there. For the purposes of demo, I have not included authentication, but of course, when you want to manage session, when you want to identify who the customer is or what the customer is allowed to do, you definitely need authentication and authorization. Proceeding ahead, so I add a server, and as you can see, it's connected. Let me go to tools, and these are all the tools that we just went through. I'll run the tools one by one. The first tool is create a ticket direct, which is a direct MCP tool, one-to-one mapping with the API. So here it's john@acme.com. I would say upload button is unresponsive and something like needs urgent, and let me run it. All right, this is the structured content. This is the text, which is the unstructured content I was talking about, but structured content really helps the model to understand and plan tasks better. A ticket got created in this case. Let me go back. So the customer is CUST1, ticket is 2, and I'm going back here. Now I need to open a ticket by following the second pattern, which is aggregate ticket creation and auto-populate a note. Again, let me take john@acme.com, and the problem is download button is not working, and run. So you see the ticket is created for this customer, and explicitly we have passed the email ID, and as you can see, a note is also created. And this is auto created from support intake. It aggregated the three things into a single Semantic tool. Now, let me go to the one where we manage the information for the session. The reason I'm going through these tools, this will be the exact same if you go to the chat capability or if you use VS Code's MCP client or some other MCP client like Windsurf or something that supports, of course, local development. My prompt would be something like the further operations that I want to do are for this customer. And that's how basically this tool will get invoked. Assuming all that prompts related thing I'm keeping aside and specifically focusing on tools, I'll pass John at acme.com for select customer. Now, as you can see, the customer object is returned and also now saved it against the session ID in memory. Now I want to create a ticket. This time it doesn't ask me for the email. Let me say customization can be improved and the description would be accept logo URL as PNG. And this is my ticket for the customer one because for this session, the set customer is COST1. And this is a new ticket that got created. All right. Now, basically, whatever we are doing in this case, the agent would be doing. So the agent doesn't need to really copy TICK4 to add a note. All we need to do in this case is add a note saying the customization logo support PNG image links now. For that ticket, a note got added. The engineering team added the support for this and notified it on the ticket, did a lookup against the session ID from the state. And now, lastly, just simple debugging status tool to see what is in our session. This is our session ID, this is our customer ID, and this is the ticket ID. This pretty much explains the three type of patterns that we talked about, and the fourth pattern is a hybrid pattern. Essentially the entire thing, if you combine all tools into one, not as a single tool but the entire MCP server, you would see that there is a direct tool. So hybrid basically talks about that you are having different needs, different use cases, and some tools follow a one-to-one mapping with the endpoint. Some tools prefer aggregation and other tools makes use of the state management against the session ID or some other parameter. That's the hybrid approach. This entire MCP server is an example of hybrid, and otherwise individual tools or the set of tools follow their own patterns. Please let me know if you have any questions. Always happy to chat. Thank you.